very human drive to like, let's make everything a chatbot. No matter like, even though ultimately conversation is just language is just another interface, but people try to build like the most elaborate chatbots for booking flights, for doing all kinds of things, including things that could have just been a button. And that died down slowly because I think people also realized that the tech is the one part, but actually there's so much more about even building a chatbot for something useful. Like, what should it do if it fails? That's not an AI question. That's a product question. Or, cool, you can order food with a chatbot.
Hi, friends, and welcome to Leading with Data, a podcast where we talk to the global leaders in AI and ML and bring their perspective for you. Today, I have with me Ines Montani, who is a developer specializing in tools for AI and NLP technology. She is the co-founder and CEO of Explosion and a co-developer of spaCy, a popular open source library for natural language processing in Python. In fact, I think it's probably the most popular library for NLP tasks in Python. And also Prodigy, a modern annotation tool for creating training data for machine learning models. During the discussion, we talk about her journey, her perspective on generative AI, and how she sees future about generative AI. So go on and listen to the podcast.
Hi, Ines. Thanks for taking time out from your schedule and welcome to the show.
Yeah, thanks for having me. Yeah.
Sure. So, Ines, last time I spoke to you, that was back in 2017, and obviously a lot has changed since then. But would love to hear from you in terms of your journey and how did let's say very briefly, because we had covered that before, so the start of spaCy, but I would want to focus more on what has happened since 2017 and the more recent developments at your end.
Yeah, so I need to actually remember what we were doing in 2017. But yeah, I think 2017 was when we were actually, we were just working on Prodigy probably, which is the annotation tool we ended up releasing, and like basically thinking a lot about the role of data for NLP and how we can make it easier for the community and for users who are like increasingly using spaCy in production and shipping things. How to make it easier to not just use off-the-shelf models, but actually train their own. And I think that's really been the through line of our work since, spaCy has evolved a lot with a lot more components. We've seen a lot more use cases of what people are actually doing in terms of extracting structure from text, and also, basically providing ways of people to build models that do exactly what they want, that they can ideally run in-house, run locally, develop just like you would develop code. And that's kind of also led to what we're working on right now, which is, of course, there are a lot more models available now that can do really impressive things. But often in industry applications, you really only want like a subset of that. You want something super specific. That's where the value is. And so how can we take what's out there and allow people to build their own custom solutions, and also work around a lot of the problems that you have with black box models, with APIs, and basically let developers take back control of their stack and of their NLP.
Yeah, and Explosion.ai is very uniquely structured in the way it is, right? So there is obviously spaCy, the open source library. There is also consulting, which you do. There is spaCy LLM now, and
Prodigy.
so just want to and just want to understand how you kind of look at the overall structure of the organization and focus areas, and then how does it all come together?
Yeah, so the idea with spaCy was always, to build a business on top of that, because we thought, hey, if we have a library that is used by people in production, there will be more that we can offer that goes beyond just the open source library. But it was also always important to us to keep the open source library open source, because even though there's a lot of value in the code, the real value comes in the things people build with it. So we didn't want to adopt a model where we lock off some features of spaCy and make them paid, for example, or where we really just offer support for spaCy, because then you're kind of in this weird situation where you can't make it too easy for people because otherwise they don't need you. So we're like, no, we want good docs and we really want it to be easy to get started. And so if all we monetize is helping people, that's not really working. So that's kind of how we went into this. And we've also always wanted to make sure that we preserve the value of the open source and not bet all of the work and all of the value we've provided on some big venture outcome, because I think that can also be quite harmful for the community. So so that's why pretty early on, I think probably shortly after we spoke the last time, we really saw data and working with data and training models, that's really the pain point for any expert user or any power user of our stack. So we built Prodigy, which is an annotation tool that was really designed as a developer tool, because even then, I'm not sitting here and saying, oh, we foresaw everything that happened in the field. But I think even at that time, it was already clear that models were getting bigger and better. And also this idea of transfer learning, or being able to train systems with relatively few examples and being able to transfer knowledge about the language and the world, which was always the big problem in NLP, that was very promising, and that this would be a path forward. And that also means that this idea of big data, or creating huge data sets, making it like this boring click work that you put on Mechanical Turk, that this would be outdated, and that creating data would be more something organizations do in-house. And that's kind of what motivated and inspired the idea of, hey, let's build a product for that, and make that a completely separate product, make it adopt a pricing model that's attractive for developers, where you pay up front, you have a tool that you work with, back in the days when you could just buy Photoshop. So that's how we designed that avenue. And then we've also always thought doing some consulting or working on real world use cases and using our own software is really important. If you're building developer tools, you need to know whether what you're building is useful. And so we didn't want to just become entirely consulting based. We think it's super valuable to use our own tools. And we've actually we had a list internally where we collected fixes that just came out of using our own software. And you're like, why is this API so bad? Who wrote this? And you're like, oh, I wrote this. Okay, we need to fix this. And that's very valuable. I'm just seeing what people built. There are so many interesting use cases, and often these use cases are not these fancy futuristic, oh, we're going to solve every problem with AI. It's often something very specific and something that's hugely valuable for an organization. And seeing these use cases and how our tools apply was also very important. So that's kind of how we ended up with this structure. And
And from your lens, right, how has been the generative AI wave, and for you personally? Because I'm presuming you obviously were so ingrained into the ecosystem, so you could probably see some of this coming before the larger world kind of
I think
realized
most people who were following things there's something happening there. I think for many people, even those who've been in the field for a long time, it was definitely very impressive to see, okay, if we just go and make these things so much bigger and just throw that much money on it, we can get these very good results. It's just something nobody had really done before. And then, so I think that was definitely, very, very impressive and surprising that, this happened so quickly. But it's definitely, something we've been looking at, and also thinking about, okay, how does that fit into the larger NLP workflows, and also what problems does it solve, and where do we still need custom tooling around it? Because there is this like one view that some people have where, okay, everything becomes this like few shot, zero shot problem, and in the future we won't need databases anymore, and in the future we don't need structured data anymore. It's just like you just want one model, and that can do everything. And we've always seen it more as they're kind of two ends of the spectrum here. One is lowering the floor, which is like the barrier to entry, and the other one is raising the ceiling. And so just like with websites, it's now much, much easier to get started, and everyone's grandma can set up a website. At the same time, there's still so much work happening on the web, and it's, if even building the browsers, building new technologies. If you're a company like Netflix, it's super valuable if you can make your little in-browser player 0.1% faster. That like is a huge deal, and people are working on this. And that's I think that's an important distinction. And we've also always seen that the things people are trying to solve in industry, there's a lot of new stuff you can do now with generative AI, and that really wasn't so possible before. But at the same time, there's also this fundamental thing people have been trying to do since before computers, which is structuring unstructured data. And with computers, it's faster and easier, but there's kind of no shortage of problems that companies have. And a lot of it, I do believe that structured data is very important, and it's something we're very interested in as an industry. And I do also think there is a lot of value that a lot of the new technology and also generative AI can provide, but I think it's not as simple or unambitious as, we just need bigger general purpose models. That's one way, but I think there are better ways.
So from your experience, when you try and apply these generative AI technologies to specific industry problems, what are some of the common pain points you have come across in these implementations? And I know, for example, spaCy LLMs are addressing some of those problems. So how is that? So what are those common problems, and then what are the ones where a solution like spaCy LLM or other solutions can come and help address this to some degree?
Yeah, so I mean, there definitely a lot of aspects to that when you start experimenting. Also, it's all still very new. Like people often talk about prompt engineering as if it was this like established science, but a lot of it is just like you try something out, and we have very little insights into how a lot of the models work. And it also doesn't help that a lot of them are not even open. Like we don't know very little about GPT-4. We can just try things out, and there's some best practices, and you can look at the research. So even just that part of, okay, how do we get better insights into how the model works, how can we access the right information in the best way. That's definitely something where we've been trying out different ideas, different approaches that came out of research, because we wanted to make sure to have like good default built-in prompts, and that people can customize, but also have it kind of work out of the box. And then the other part is not all business problems, or most business problems, are not general purpose. They're often like super specific about specific terminology. The valuable stuff is actually things that are business internal. So there are these capabilities about understanding, or quote unquote, understanding the language and the world that are useful. But when it comes to the specifics, you still don't necessarily get good results out of the box. And the results you get are plain text again, and then you're kind of roundabout, then you're using NLP to turn that text back into structured data. So I feel like we're kind of we sort of in some ways back at writing rules and instructions, where we were before learning, and then we were able to program by example, and now we're back at writing rules and instructions. And there are kind of pros and cons to that. It's, writing a natural language prompt is definitely very accessible, but there's also you need to think about this whole system's behavior up front, and that is actually quite difficult, because if you're really looking at the examples, you can often intuitively say, hey, that's the behavior I want, but you're not necessarily able to articulate it in any form, or then in a form that's useful for the model. So that's another problem. And then also, I think what a lot of people in the industry are observing, you have, these models are incredibly large. It's not economical to run them yourself. And it's also, unfortunately, it's not true that just running an open source model is cheaper, because the large API providers do have economies of scale. So that's definitely a problem. Or even just, you're dependent on someone else's API. The model can change tomorrow, which people have observed as well. Like there's no deterministic output. And, you have like, if the API is down, then the API is down. You have no data privacy. You need to send stuff to someone else. And I think these are actually things that are super important in industry. And that we currently don't have a good solution for. And I think the solution, just, bigger models for everyone and spending more money isn't necessarily the way forward. I think there are better ways. And also there's all this knowledge that we've gained about best practices, about how software should work. And AI development is still software development. And so, you want different building blocks. You want pieces that you can fit together. Just like when you're writing code, you're not putting everything into a single function. That has so many downsides. So, these are not, the problem here isn't that, we just have this new paradigm that everyone needs to adapt to. It's that, hey, we have already solved a lot of these questions before as an industry, but how can we now come up with workflows that support that, where, yes, you can use the latest state-of-the-art models, but also end up with something that you ship that's modular, that, that's also, that you have insights into, that you can explain. These things are, kind of, some of these things might sound boring, but it's actually what's incredibly important. And so, I think these are all challenges we've seen, and some of them we're able to address with something like spaCy LLM, where we've built different components for structured prediction tasks, like classic things like named entity recognition, text classification, but also relation extraction and things that are a bit more complex. And these components take care of the prompting and parsing for you. So what you get out at the end is a structured doc object that people might already be familiar with from spaCy. So you have like the same output in your prototype, in your production system later on. And it definitely solves a big part of the cold start problem that previously people had, where you need at least, we usually say 40 hours of work until you get a model that does something, and then you can improve that. And often, from experience, you spend that time and then the model doesn't learn anything. And you're like, why is it? Did I set my hyperparameters wrong? Is my data bad? Did I have a bug in my code? And that's really this bottleneck is really something that we can address now. And then you have a model and you can improve upon that. And you can actually then basically, start by refactoring it. Because ultimately, just like with code, it's a refactoring task, and say, hey, here's one part of the solution that I can separate out. Or, you don't need to have one single model do everything at once. You're making it a lot harder this way. Like, here's maybe something that you can do with a regular expression, and here's something where you can train a task-specific component, and maybe here's something, summarization, where you do use an LLM, but you might use a smaller one. And this kind of workflow idea is something that I think, it's all still very new, and it's all still changing very fast. But I do think that's something where tooling can really help. And then I think there are the bigger questions around data privacy, around reliability that really come down to a bigger workflow thing, like how can we do things differently? One thing we've been trying out a lot is what I've called human in the loop distillation, basically going from a larger model that's generative, general purpose, and then using the output to train a smaller model, and ideally with the human in the loop, because then you can actually make it better. And this works really well. I mean, at least so in the experiments, and it also logically makes sense. Of course, we can improve a model with more data. That's pretty reasonable. And so I think that's actually, as a workflow, that's a really good answer. But now the challenge is, how can we make this workflow at least similar in terms of user experience to writing a prompt? And that did introduce a new standard for how easy it can be to get started. And I think actually, these questions around that's really what we're really focused on a lot at the moment. Like, how can we make this workflow that's a lot better and that addresses a lot of the issues that developers are facing, and make it more approachable for people.
And just to, from talking about some of these problems which you referred to from a very layman perspective, these would be challenges like, let's say, a healthcare company trying to use LLMs, but a generic LLM would not be appropriate because you can't rely. So you're then adding a layer with human in the loop to make sure it's more consistent, it's vetted by someone who has the right qualifications, and then can be used later on. Is that?
For example, you can start out writing a prompt. It's that's super straightforward. You have an interesting prototype, but now first step is, you need to identify what are the underlying tasks that I'm trying to do here. I'm trying to classify text. Maybe I'm trying to extract things from text. So that's the first challenge of, how do I decompose this problem? What's my business logic that's like completely internal and has nothing to do with language, and what's general capabilities? And then, you need good tooling to put the human in the loop and have the human annotate and correct. And I think here it's important to consider the weaknesses and limitations that a human has. Like, you can't approach a human the same way you approach a machine learning model. We're actually, we're really bad at a lot of things. We can't remember things. We're really bad at performing a series of steps in a row reliably and consistently. We can be inattentive. We can make a lot of mistakes that a machine would never make. So you need a workflow and tooling that helps with that and lets you break down the questions into something that the human can do much better and as reliable as possible. So ideally, less clicking. If you can ask yes or no questions, that's awesome. Focus on efficiency. And then you have the data, and then you need to have a smooth way to train a model, and also do that until you've beaten the baseline, essentially. So that part, in theory, you just keep going until your workflow says, "Bing, you've exceeded the baseline with that we had with GPT-4." But then you also need good evaluation. That's another thing. Otherwise, and that's also something we might know this, but if you're kind of coming into the field, that might be less intuitive. And I've also seen, while large language models can also help with evaluation, it's not like you almost always want examples where you know the answer and you're like sure about the answer and the answer is correct. If you're I've seen people just saying like, just pass it to another LLM and let it evaluate it. And that can give you some insights. If you integrate this into your workflow correctly, that can definitely work. But it's not like you don't actually gain any insights into how your model really is performing. And So
And
these, yeah,
yeah, thanks for sharing that. But I was just trying to draw a parallel analogy in terms of, for example, how data science and machine learning evolved, right? So there was this initial uh, very high focus on getting the algorithms, so you're boosting models, etc., which saw surge, a lot of interest. But then quickly people realized that the data infrastructure and the engineering around that is a lot more important.
yeah.
And I feel with generative AI and LLMs, we are probably again in the similar space, that there is a lot of excitement about what they can do, but ultimately the minute you start using it, your tooling and your consistency starts becoming more and more critical. So
I feel like
is
it's always the same way. So yeah, those who've been in the industry for a while, I think a lot of it, the current situation, or like reminds me a lot of the first chatbot hype in 2015. I don't know if you remember that,
yeah.
or people listening if you remember that. Basically, yeah. To those who don't, there was also a lot of excitement because finally chatbots and conversational AI was sort of working. Like compared to what we can do now, it's like was pretty bad. But
Right.
there was a lot of excitement in NLP, and I think there was also this kind of motivated this like very human drive to like let's make everything a chatbot. No matter like even though ultimately conversation is just language is just another interface, but people try to build like the most elaborate chatbots for booking flights, for doing all kinds of things, including things that could have just been a button. And that died down slowly because I think people also realize that the tech is the one part, but actually there's so much more about even building a chatbot for something useful. Like, what should it
Right.
do if it fails? That's not an AI question. That's a product question. Or, cool, you can order food with a chatbot, but how does it actually work? Like, do you have a database that you can look things up in? Do you like
Yeah.
how should it all come together? And that was actually, I think, even if you look at a lot of frameworks that were around, like Rasa, for example, they started around that time. A lot of the focus there is also on this dialogue management and all of the operational development stuff around it, because that really matters. And I think we're seeing a lot of the similar
Thing.
drive or hype at the moment, where people want to make everything a bot, even though maybe sometimes it should rather be a button, or but I think it's part of us as humans. We always try to imagine solutions as, okay, let's take the task the human does and let's map it one-to-one into technology. And sometimes that works, but in a lot of cases the solution actually looks very different. Yeah. And I think also right now, yeah, I think I previously called it like the post-hype hangover. I think there is this
Okay.
sort of phase of, okay, there was all this hype, but now things are still hard. And of course, AI and technology isn't magically going to solve all the problems that are not fundamentally AI problems. And people are starting to realize that. And there were a lot of people who have realized that all along. And I think there's a bit of disillusionment as well in the general developer community, because people feel like, well, of course we're not going to throw away everything we've had in production for years and replace it with like some API that's like worse in all categories. Like, why would we do that? But yeah, it's it's how these things sometimes go.
Yeah.
And then I think also just the mainstream interest. I think it's great that I can explain to everyone now what I work on. I can say, oh,
That is true.
like, oh yeah. So it's like there is at least some understanding, and I think the timing was great because a lot of companies were getting their budgets cut right before ChatGPT really entered the mainstream, and now people have money for AI again. The teams are happy they can continue working, but at the same time, there's an expectation management to do, because a manager comes back from some conference and wants everything to be generative AI, and the developers have to be like, well, look, yes,
Yeah.
and also no. I think I talked to a lot of developers at conferences, and that's definitely a theme. And then also, yeah, the mainstream community, I think for a while, like all the well, a lot of hype people who were previously in AI, they went to crypto momentarily in between,
Yeah.
and now a lot of them came back to AI, and maybe there's something new that they're all gonna move to. So people get to focus again.
With less than 30 days to go for DataHack Summit, we are all prepped up to welcome you at the India's most exciting and most futuristic conference in generative AI. Companies like Google, Intel, Merkle, and a lot more have already confirmed their participation, and the agenda for the summit is out now. So go ahead, have a look at the agenda, and make sure that you mark the sessions you would want to attend and be there at DataHack Summit. I'll see you at the summit. Thank you.
From your perspective, if I talk about, let's say, next 2 3 years or whatever time frame you want to talk about, what are some of the key trends you expect in the industry, and then how would, let's say, some of these workflows or how we build AI using generative AI for industry solutions would change in the coming years?
Yeah, I mean, it's never easy to predict
Yeah.
exactly what's going to happen, but I also do think humans tend to overestimate the future
The
progress. Like, of
short
course,
term.
and there is a lot of stuff happening, and technologies are improving, but it doesn't necessarily mean that like in a few years we'll all be ruled by AI. Just like how compared to the moon landing, at that time people thought, oh my god, in a few years we're going to be on Mars, and it's not necessarily that linear and how it works. So I think that also makes it a bit tricky, but I do think actually we're already seeing a lot of movement towards smaller models. There's definitely a lot happening in the open source space, and I do think it's only reasonable to look at models getting bigger and getting better that way, and then going from there and saying, okay, but what if if we can make them bigger, how can we make them smaller? It also means that, like, okay, if we're we're focusing on specific areas, or if we're focusing on specific types of tasks, how can we make all of this more compact? If we don't need a bot that we can talk to about the weather. So I think that's definitely an interesting area, and I think that's also for industry very relevant, because there are a lot of areas where even for structured prediction, generative capabilities can help. Like, you can summarize something and then predict something on top of that, and there's definitely a need for that. And I do think we'll be able, like the same way we can make bigger models, we can also make smaller models. And I do think also there will probably be more discussion around questions like data privacy, explainability. People are really rushing these solutions out, and I think there isn't much oversight, and there maybe isn't, nobody wants to miss out. There's a lot of FOMO, but I do think there will be probably some prominent cases where there are significantly negative impacts, and that, as a community or as a society in general, we can discuss. Because I think right now, yes, it's something people talk about, but there's not that much focus on it. And yes, internally, companies are issuing memos like, hey, don't put our internal legal documents into ChatGPT, but it's all very lax. And also the questions of where does the data come from? Like, what can models just reproduce? What can leak? These are all things that are very important. There have been cases like this, but I think inevitably we'll see more of that. And I think also come back around to questions like, okay, we can build an AI system that can do something, but who's responsible for that? Like, companies will still want to have a human at some point to to approve the decision. And I also hope companies are not rushing to lay off a lot of people, thinking they can replace them with AI, only to then realize that, oh shit, we've now lost a big part of our workforce, and everything we ended up with is strictly worse. So that's kind of on the more pessimistic side of things. What else? I do think I think definitely, developer tooling. There are so many more people coming into the field that don't have, the background of traditional AI. Also, as I always say, like the most interesting and the most successful projects actually that we see are from people who come in with subject matter expertise and not necessarily AI machine learning background, and then think about it from like first principles and learn programming, learn the technology. It's not, there's a lot of elitist thinking in the industry, but actually, people can totally pick up how this works and get stuff done. And I think it's kind of, instead of running around with a hammer looking for nails, people start off with nails or screws and then look for tools. And I think, now with it being more accessible, I think that will continue. And I think also people are also now realizing that a lot of prototypes don't actually translate into production systems. So there's this plateau. We've had that before as well. Like when people were first starting to get excited about AI, and this usually happens. And I think, there'd be some back to the roots movement definitely, and also, I think a lot of it comes down to workflows and tooling and operations and questions that are really product and application questions and not technology questions. Like, what should my product do? Should it work like that? Is this reasonable? Should this be a chat interface? Should this be a button? What information do I actually need? What do I want to do with it later? Like, we've been trying for years to have technology magically solve that, but of course, it's not how this works. Yeah.
And what are, let's say, one or two or a few applications which you are most excited about, which we could solve in, let's say, the next few years? And also, what is the scenario which worries you the most?
Okay. So, I mean, let me think. Well, I do think we will, soon get to a point where a lot of these, because that happens to also be the field I work in, working with structured data, bringing structure into unstructured text, that I do think we'll be able to actually build systems that are significantly better than what we have in production now. And not just that, I think there are so many use cases that people have that nobody had time to address yet that are similar. So I think there is there is like a lot of stuff that's possible there. I think it's not exactly my area, but I do think there's a lot of interesting stuff happening with multimodal data that I think has a lot of promise, because we're not like maybe at the end of it we want to work with nice plain text, but it's usually not that. We might have some scan, we might have all kinds of mixed data. So I think that's definitely moving forward and could be pretty exciting. And I think also, yes, I think we will at least, unless different countries mess this up with the wrong regulation and let OpenAI write the AI regulation, we will not end up in a scenario where AI in general, models in general, will be monopolized by big tech only, because there are other ways. It's not, it might not be what big tech is telling you, because either they want to sell you the models or they want to sell you GPUs, but there are ways for companies to solve practical problems internally without having to rely on massive models via APIs they don't control. And I do think unless we go really wrong there and really stifle the stuff that's happening in open source, we have a good chance. And I do think what I'm more worried, like I'm less worried about this dystopian future where AI is going to rule us and enslave us or kill us all. I think way before that, what's a lot more scary to me is ending up in a situation where people believe that AI can do all of these magical things and is good at everything and 99% accurate at everything, when it's not necessarily true. When it's like, some things are okay, other things don't quite work. But I think if people have this very misleading idea of how the technology works, I think the society we end up in is much scarier. And what's also much more likely is like humans make mistakes and humans put bugs in software, and using technologies in like bad ways, or just having bad ideas. We've all had like bad ideas that we ended up developing and then realized, oh, that was actually a terrible idea. And I think we've all shipped bugs and probably ship bugs to production. That just happens, and that will keep happening. And I think a much more likely scenario is just a developer not considering all the scenarios well enough, and there's a bug and then stuff goes really wrong. And while people believe, hey, this technology is like magical and is much better than humans and can't go wrong. And I think that is a scarier future. Yeah.
Interesting. And on the first part, which you mentioned, that you're really excited about different ways of or different kind of models coming out. From an organization's perspective, is there a, let's say, size above which you think investing in your own, let's say, models or deploying it at your own premise is more beneficial compared to, let's say, companies which are lower at scale? So how should, let's say, organization think about whether to go open source, have your own kind of setup versus relying on APIs from some of the big tech companies?
Yeah, I think that's a good question. I mean, of course, it depends on what you're doing. I think one way to think about it is whether you actually want to use large generative model and those capabilities at runtime, or whether it's a dependency you can move into development. And actually a very similar refactoring question that you might think about with code, only that here it like matters even more. And that really changes the calculation. Like if you if you have an application where you really need to generate text on the fly and need to do that reliably, if you have tons of traffic, then yes, you can maybe benefit from economies of scale, and it might actually be more beneficial to run something yourself. But if not, then you are often at a point where, just setting this all up yourself might end up costing you a lot more time, money, effort, resources, and that's a problem. But if you can move the dependency to development, then it all looks very different. Then you can actually use open source models more easily, because you're not expecting a production load on that model, and you can choose different models. You can experiment a lot more with what works, and what you ship to production is something you control, and that can be much smaller. So we've seen that even something, if you can do it, even a bird-sized model can be very, very competitive if you put some work into the data. And often the time you need really isn't that much. Like we've had, I think maybe you can link those in like the show notes later. We have some case studies that we did where companies tried this out and used an LLM, created some data, trained their own models, some of them as small as 6 megabytes, which is like really fascinating. I mean, just like think about the size of 6 megabytes, but even in some of our experiments, something like 400 megabytes, 500 megabytes, that's like pretty impressive. It's you can absolutely beat a few shot or zero shot accuracy you get from a general purpose model, and you might spend 8 hours on this, and that's like, or even if you spend 40 hours on this, that's like a work week. I think people still view this bare bones, like working with data aspect as grunt work, when it's actually it's really the core of your application, most likely. And if you think about it, like we've all spent more time getting a GPU to run or installing CUDA than we might spend creating some high quality data that lets us train a model that outperforms a large generative model on our specific task. So it really doesn't, it does not take that much time and effort and work. It's really much more about reasoning about it the right way and breaking down your problem and thinking about what do I actually need, and that's hard. Or how can I make things easier? Sounds trivial, but actually it's not. It's something, we've had to, as a programmer, we've all had to learn how to write good code, and it's the same with data and same with training models. But with experience, we can get better at that. And I think that's the real hard part, not training a model or even annotating data.
Sure. And with all the experience and then the success you have had, what would be some pieces of advice you would give to, let's say, young people who are entering this domain? What should they keep in mind? How should they think about coming years from their own career perspective and domain perspective?
Yeah, I mean, I think I always say, like, I hate, I don't like giving advice because everyone's, situation is so different. And, don't follow advice from some random person on a podcast. But, I mean, it's difficult because my career and my background hasn't been very typical. Like, I don't come from a classic computer science background. I just sort of, ended up in this field where I noticed, like, hey, I can combine everything I'm passionate about. And I think it's a very different situation nowadays, like getting into the field. There's like, a lot of hype, a lot of interest. It can also feel very intimidating. But I think there's definitely, there's a lot of value in, like, developing your core skills rather than focusing on whatever the latest library is or whatever the latest technique is. Like, should you focus on prompt engineering or should you focus on this thing? And I think there is a lot of value in really knowing the basics and knowing the foundation, which is, of course, you want to, if you want to become a developer, you want to be able to program and really be able to write good code. You want to write efficient code. You really want to, you want to know how to refactor, how to do these things. And that's also knowledge nobody can take away from you. And that, as we've talked about today, it always comes back, and it always becomes relevant again. And I think if you can do that, you're much more prepared for whatever happens in the future than if you focus on a specific technology that people might not care about anymore. And it's actually like being able to really think about how an application should work and making good decisions for how do I break a problem down into things that I can actually solve, and how does it all come together, and how does it relate to the application? That's non-trivial, and that's like always important in any work you'll probably be doing in applied NLP or applied machine learning. And I think also a lot of people, as I said, coming into the field have like some other subject matter expertise or something else they've done before, something they know about. And I think that's also very valuable to kind of have a connection to something you're trying to do with the technology, and not just machine learning for the sake of machine learning. Like, that can work in more of an academic career, but I think for applied work, you're always trying to do a thing. And if you want to work with NLP, I think also getting some basic understanding of how language works, because that's always going to be relevant. And they are like things inherent to language. It's how we communicate. It's how it's how we express something through language and through text. And you don't need to study linguistics, but having thought about these things before and having some understanding can really help, and it can help you build better solutions. And especially for people who come from a background where they might have not learned a lot about grammar or language, or where they might have not learned a second language as well. So I think we both probably speak. Well, I mean, I speak 2 languages. you might speak more, probably, but yeah, there are a lot of people who know English and haven't really had an opportunity to learn more about language. And English does tend to, like, a lot of problems you have in other languages don't really come up in English, and so there are concepts people have never thought about, and that can really limit you when you're designing NLP solutions. So
So thinking from first principles and then being very focused on the.
And I think core skills that translate well, rather than just library APIs. Those are things. If you have the core skills, it probably will be much easier to learn some specific library. But that was basically the point.
Thanks for sharing that. Also, we are honored to have you at DataHack Summit, which is coming up in August. So really excited about that. Can you share a bit about what to expect from your keynote at the summit, and what would it be like?
Yeah, no, I'm super excited. Like, I've only been to India once, and I was in Chennai, and so I'm really excited to be back. I know there's like a huge community there, and I'm already bracing myself for the weather, and it's probably going to be hot. And I'm already sweating here. So anyway, so my keynote will be titled "Applied NLP in the Age of Generative AI," and it will actually go into very similar topics of what we talked about today, like what does generative AI mean? What does it maybe not mean? What's possible? What can we do? How should we think about systems that we're designing? What does it mean to think beyond chatbots, for example? So I think actually we talked. We touched on a lot of the ideas that I will show in more detail, and also what does it mean to factor out your business logic and design applications, what works, what doesn't. And then my co-founder Matt will also be giving a talk that's a bit more on the practical implementation side. So
Great. Thanks for sharing that. Ines, towards the end of these episodes, we do a rapid fire round with our guests, and the idea is just to know you better as a person, right? So what we would love to hear is whatever comes top of the mind on the question. So the most fun NLP application you have built or you've seen built?
Oh, fun. Define fun. That is really hard. I don't want to single out any specific. Like, I know they've like, there are a lot of these niche things. Like, I think a friend of mine built something for Star Trek, like analyzing Star Trek. That was fun. I think someone built Hobbit spaCy for like Lord of the Rings. There's a lot of these like hobby. I mean, in terms of fun, just where you could tell like, hey, this isn't necessarily super useful, but someone just had fun with the technology and applied it to something that they enjoy, which I think is also actually a great way to learn. I always like find yourself a project that, even if it's Lord of the Rings or Star Trek, do something with that, and learn. Yeah.
Interesting. And any particular book which had a big influence on you, or which you would love to recommend to people?
Book. I don't actually read many like tech related books, because
Yeah.
I find it very difficult to like really. I've never really learned to really study. Like, I need to do a thing, and that's like, that has pros and cons. But like, I'm really bad at like sitting down with a book and going through it. So I don't. I really can't think of anything I would.
And any
Um,
non-tech book which had a influence?
oh, oh, in, I mean, that's a tough question. I need to. I can't think of anything that really had like. I mean,
We'll pass
that
this way.
that I would also. Yeah, that really makes sense in this context. There's a lot of books I liked, but yeah, I probably
Sure.
after this, like I'm sure, like after this, I'll be like, oh my god, there's like this one book that I should have totally mentioned here, and that would have made me sound really smart, and like that perfectly answered this question. But I really can't think of anything.
Sure. And what does a typical day look for you?
Oh, really, like not the sort of Instagrammable like day in the
Yeah.
life, but like real day. Oh, yeah, it's actually pretty boring. Like, it's like, I get woken up by the cats who want food, which is like increasingly earlier, and then
Mhm.
I go to my office, I have caffeine, and I start looking through stuff on the internet. I make like a to-do list, updates, see what I have to do for that day, and then like it's actually kind of right here. And then I basically continue sitting here for a big part of the day. And then sometimes I leave the house. I do chores. I do social things. I go to concerts. I enjoy various media, but like really in terms of my work, the typical day, I just mostly sit in front of my computer. And even in my free time, I just like doing things on the computer. So it looks very boring.
Okay. And one thing you always carry when you're traveling?
My phone, my headphones. Sorry, this is incredibly. This is incredibly boring. I travel. Um, Well, if I'm traveling for work, I always carry stickers, because I always like making stickers for our tools, but also really fun NLP designs. And I will also bring them to DataHack Summit,
That would
and
be
that's
fun.
a huge bag of stickers I always take, to every conference I go to. So yeah,
Okay.
if you
So
see me,
looking
ask me
forward
for
to
stickers.
that. I would. Sure. Thanks a lot, Ines, for taking time out and sharing,
Yeah.
your perspective and your journey. And looking forward to having you at the Data Hack Summit.
Yeah, I'm looking forward to hopefully meeting a lot of people in person.
Yes.
Yeah,
Sure.
cool.
Thank you.
Thanks so much. That was fun.